Okay, in this video I just want to explain to you what we did in the classroom with the Gettysburg Address exercise. So on day one, this is actually a 2-day kind of thing, I asked students to randomly select 10 words and just circle them in the Gettysburg Address. So then after they did that, and I've asked you to do this also in the web class before you viewed this, write down the words and then just count the number of letters in each word. Then I had the links of those words entered into a spreadsheet, and you can see the document where I've attached it has the data that I collected in the classroom. I'm not going to collect data from the web students, but I think completing the exercise in a minute or two will help you understand what I did in the classroom. So on day 2, students broke up into groups. I gave them the sheet of paper with the 95 observations. In that sheet of paper, each row was one person, and then there were 10 numbers there that would be the length of the words that they selected when they circled words in the Gettysburg Address. Anyway, they would roll the die twice. The first time, let's say they got a 7, and the next time a 4. So they have a 74. Then they would go down on the sheet of paper to the 74th person, and then compute the mean for that person. So there would be 10 lengths of words. They would just add those up and divide by 10. Repeated that 5 to 8 times, depending on the size of the class. One size was a little larger than the other one, so they just did it 5. And the smaller class did it 8 times. What they end up with is 5 to 8, depending on which class they were in, sample means that they had computed from randomly selected samples. Just as a side note, when they selected their sample, since I had 95 individuals listed in the spreadsheet, if they rolled a die and got a 9 and then rolled another one and got a 9, they just redid that because 99 wasn't in the larger sample of the population, really, if you want to look at it that way. Also, if they came up with 23 both times, they had to redo because we didn't want the same person in twice. Then after they did all of that, they had their collection of sample means, 5 to 8 sample means. I had each group read the collection of sample means, and I plotted them on the board. And that's what it looked like. So each time I have an X bar, if someone read an X bar 5 or 5.1, I wrote an X bar down here. If they said 7.2, I put one over here. So 2 things. This is the curve that we drew from the means that the students computed. There's 2 things you should notice about that. First of all, the true population mean is down here. It looks like when people picked the words they missed, the mean that they selected as a class would have been somewhere up here. In fact, if you use all of the data that students collected, the 95 students and all 10 words, so 950 words, the average that they had was about 5.8, but the real average is 4.29. One implication of that is, and this is generally true, it's not surprising to me, human beings aren't very good at selecting random samples. You need to use some process to generate truly random samples. We used dice in the class, but you could use random number tables, statistical software. I'll give you a link to an online randomizer a little later. One point of this exercise is we're not very good at sampling. We need some way to make sure that the samples we select are random. Okay, there's another thing, and you can maybe see it by the outline that I drew there, and that is that the distribution of those means did follow a bell curve. And that is a central idea or fact in statistics, and that is that distributions of statistics tend to follow a bell curve. Now, you won't do this very often. This means that we calculated the sample mean a bunch of times. In a real situation or a real study, you're just going to collect one sample mean. But what we will know about that sample mean is it comes from a process of calculating sample means that follows a bell curve. More on that later. I just wanted to get you introduced to that basic idea that distributions of statistics follow a bell curve. And let me go on to say, even if the population is not a bell curve. This is just another picture of that. This actually comes from an applet based on this exercise. This is what the population of word lengths looks like in the Gettysburg Address. And you can see it's a pretty skewed distribution. Now here's what the distribution of sample means looks like when I took random samples of 25. I think I took 1,000 of them. But you can see that doesn't look skewed. It looks like a bell curve. Also, you might note that the mean of this distribution, the mean of what we'll later call the sampling distribution, is pretty close to the mean of the overall population. And here's just the same picture, or a little slightly different picture of what was on the last screen. Here's the population, skewed to the right. There's the sampling distribution. They have about the same mean. The other thing you might go ahead and just notice now, again, this won't be really big in the course for a couple of weeks, but this distribution is a bell curve, same mean, and it's narrower. More about that later in the course.